channel. I'm Meghna Menon, and today I'm going to be talking about the boiling point, the freezing point, and the effect of adding a solute to a solvent. So what is boiling point? It is the constant temperature at which the vapor pressure is equal with the atmospheric pressure, and any liquid will turn into its gaseous state and starts to boil. So for this I have measured 250 ml of water and I'm just going to pour it in. Right now the temperature is 29.8. Fixing my thermometer with this dough, and as you can see that the temperature is rising. I hope you can see that the temperature is rising. So the atmospheric pressure is putting a pressure on the water molecules, but the point comes where the atmospheric pressure and the vapor pressure is equal. So the water molecules turn into the gaseous form and they start to bubble up. So as you can see that little bubbles are coming over here. But still the atmospheric pressure is more, so boiling is not happening right now. So the water is taking the heat energy and turning it into its kinetic energy, and it is turning into its gaseous form. So you can see that the vapor is coming out over here. And this vapor, which you can see, is forming the vapor pressure. Boiling happens when the atmospheric pressure and the vapor pressure are equal. So the atmospheric pressure puts a pressure on the water molecules, so they can't make bubbles. But a point comes when the atmospheric pressure and the vapor pressure get equal. So what happens that the water molecules start to bubble up and turn into a gaseous form, and this is called as the boiling point. Constant between 100.4 and 100.5 centigrade, and you can see that the water is bubbling and boiling over here. So this proves that atmospheric pressure plays a role on the boiling point, and this is like when you go on higher altitudes like Mount Everest, the atmospheric pressure is low there. So the water over there gets boiled at 771 degrees centigrade. The effect of adding a solute into the same solvent and the effect on the boiling point. So I am adding some salt, and I have not measured it, I am just eyeballing it. Now the solute has replaced the water molecules on the surface that are forming the water vapor. Let us see at what temperature the water boils now. So ideally it should be more, because the same amount of water vapor will be needed to be equal with the atmospheric pressure. So more amount of heat is required to form the same amount of the water vapor pressure. So now it is dropped on 104.3 degrees Celsius, as you can see, and the water is boiling now. So clearly the boiling point of water has increased. So guys, I've finished my dinner and now I am craving for ice cream. But if I make ice cream now, it won't be ready till tomorrow morning. So I'm going to be using some science. So here's some cream and I'm adding this in the Ziploc bag. Okay, so I'm going to add some sugar. This much. So now I'm adding 2 teaspoons of vanilla essence. So now I'm adding some ice. That's such a big. So in order to decrease the freezing point of the ice, I'm going to be adding lots and lots of the salt. There, when I add the salt, the bond of the water molecules and the bond of the solute and the solvent gets stronger. So what happens is that the freezing point decreases because more energy or heat is consumed to break that bond. So that's why in the ice cream parlors they put some ice. Salt on the counter. So now I'm adding my mixture in the Ziploc bag with the ice. And now I'm going to shake it. As you can see that the temperature has come below 0, which is the normal freezing point. Already 7 minutes have passed and I can see some salt water, as you can see. So the ice cream I think has started to freeze. So why this is happening? Because the ice is taking the energy to turn from the solid form to the liquid form by using the heat that comes from the internal energy of the ice. So this decreases the freezing point to below 0. So as you can see that the temperature has come to minus 16 degrees centigrade. Still there is water, not ice, because the salt decreases the freezing point. So you can see that there is the water over here. So that's why in cold countries salt is sprinkled on the roads to keep the ice in the liquid form. Exactly 15 minutes has passed, guys. So let me see if our ice cream is ready. There is a lot of water. Take this spoon and try. So guys, it's frozen. So the ice cream has formed. It's really frozen, if you can see over here. You can see that it is frozen. So I'm going to try it now. Oh my god, it's really good. It's actually good. Yum. So I'm digging into my ice cream, and you also make this ice cream in 15 minutes at home, because I know that I'm making you hungry. And wait, don't forget to like, share and subscribe to my channel. Bye!